Good morning, Dr. Noor Hisham and Dr. Aban Mohammed Nizam. I'm Tang Hong Kong. Today I'm going to present my project CAD, which is titled as Prosthetic Leg. So for introduction, I will introduce my company. My company name is PDR Company. It's a manufacturer the prosthetic part for disabled person who has lost his or her leg or arm. And our vision is everyone can move. The goal is to provide the best quality with affordable cost of prosthetic part to everyone who need it. Also, we develop it by specialists from different backgrounds who are really specialized in R&D field. And the new product improvement will be discussed in this study. For the problem statement part, we know that the amputee in Malaysia has increasing recently, and is actually now have around 160,000. And it will continually increase until 38.5 million in 2040 based on the research. And in Malaysia, also they have not much company provide the prosthetic part service. And the previous prosthetics is really not user-friendly in terms of design, weight, strength, flexibility, and reliability. So for the conventional prosthetic leg, actually much heavier, will cause the user hardly to work and discomfort at the time. And also based on the William Levy, the skin of lower limb having a skin infection or irritation due to the sweating at the socket part and a poor hygiene at the time. For the objective is to improve the comfortable of the prosthetic leg. And second one is to design a prosthetic leg that is efficient for the user. And third one is to provide the movement based on animation and material simulation of prosthetic leg. Now going to the methodology part. For the first, which is component analysis. So component analysis is the early stage of problem identification. So they have a three is a system component, subsystem, and a product. So system component is the engineering component of the part, while subsystem component is the super system component, which is the thing that you cannot control. So in this product, the system component is a socket, knee joint, filon, and a foot. And the subsystem component is a temperature, and which I cannot control. And the product is the load, the human load. So for the interaction analysis is a different component of the engineering system, and each subsystem have their own connection and reaction. So in this picture, the leg hold the socket, and the socket actually hold the knee joint, and knee joint move the filon, and the filon hold the foot, and the foot will interact with the log. Yeah. So the skin actually at the type of the skin, or maybe were infection because of the socket. In the functional analysis, we need to know that each system have their own function. So for the leg, actually hold the socket, actually is a useful, and the sockets was hold the knee joint, yeah, and the knee joint move the filon, and the filon hold the foot, which is efficiency, where we can see that the arrow that I draw beside this picture, they have a useful, efficiency, and useful in efficiency. And the skin actually will be infected by the socket. This part we're going to discuss about the cause and effect diagram. The cause and effect diagram is the tools that help us to identify the root cause in a certain process. So we know that this prosthetic leg, previous prosthetic leg will cause discomfort pain to user and also very heavy. So we need to find out the cause. So we divide into three, which is socket, wet, and hard mechanical, which we know that the socket may be caused by the material problem or the design problem and causing the sweating at the time. Where for the wet part is maybe caused by the material or the design of the foot, or maybe the material of the filon. Yeah. And also the hard mechanical part is maybe caused of the material of the filon or the knee joint design. So after that, we're going to use the trace method. Trace method is a theory inventing problem solving method. is help to solving the contradiction of pros and cons to create a new, a better product. So apply these three principles to my previous prosthetics lab. So in here we have choose 4 improving features, which is weight of moving object, second is strength and ease of operation and reliability. And for worsening parameter, I choose for durability of moving object, stress of pressure, adaptability or visibility and a shape. So when I know that for the first one, when I know that my improving feature is a weight of moving object and my worsening parameter is durability of moving object. So after insert into the 3 principal table, I choose the porous parameter in eventing principle. So for second one, when I want to improve the strength in my eventing principle, I choose for composite material. For the third one is the ease of operation. I want to do cementation for my product in my eventing principle. The third one, when I want to improve the reliability, I need to do the parameter change. So here I'm going to show you. So for the first is weight. When the weight of the processing leg decrease, durability of the product can be decreasing. So like I said just now, the porous material I will choose for what I want to improve the weight of the moving object. So I need to create a hollow at the socket area and the foot to reduce the weight. Second is the strength. When the strength increases to the prosthetic leg, stress and pressure of prosthetic leg will be affected. In system parameters, I choose for strength for improving feature. Then the one worsening parameter is stress or pressure. Then I choose for the composite material. So replace the material where can increase the strength, when can withstand the high force with lightweight, such as carbon fiber, high strength aluminum. For the third one is the flexibility. Flexibility of prosthetic leg was affected by the adaptability or versatility of human. So in system parameter, the improving feature is ease of operation. Then the inventing principle I choose for cementation, which is able to dismantle every part and assemble easily to easier the user for servicing and maintenance purposes. And the fourth one is the reliability. Reliability depends on the factor of strength, flexibility, and shape of object. So the improving feature is the reliability. So I choose the parameter change, which is increase the flexibility of feet by changing the shape of feet and increase the strength by using a high strength material. In this slide, we'll talk about the conceptual design. They have a 3 conceptual design they have designed. For the first one, it's a very simple, but this solid shape costs heavy and is not really user friendly. And the second one is I improve the design and whereby improve the socket design. It become the round and I will reduce the weight of foot. Whereby in conception 3, I improve the socket design and increase the ventilation. I put a hollow and reduce the weight of pylon, the foot by reduce all the solid part and material. And I choose a high tension, high strength material as well, and where can withstand a high tension and a shock absorption at the feet at the pylon as well. So in patch matrix is a tool, is a scoring method that help us to really decide which one is the best solution and which one is the best design. So in this design, they have 3 criteria: is operation, price, and design. And in operation, they have ease of use, high efficiency, flexibility. And the price, they have a low price, low maintenance. And the design, they have a weight, ventilation, durable, and attractiveness. So concept design one is the baseline, which led us to refer. And in here, we can see that the scoring from conceptual 3 is much more higher than the conceptual design 2. Because we know that conceptual design 3, they have applied of high strength material, which can help the design to be durable and attractive as well. And for the ventilation part, because I increase the ventilation at the socket for conceptual design 3, so they have a advantage. And the weight is a much more advantage in concept design 3 because I apply the lightweight material in the conceptual design 3. But when it comes to low price, it's not definitely low price, but it's a reasonable price because I use a carbon fiber and also the aluminum and a plastic. There is an affordable price for the user. Yeah. So for the ease of use, we can see that they have actually for 3 conceptual design is same. And when it comes to high efficiency, we know that the concession 3 is much more efficiency with the improvement parameters. And the flexibility also, we can see that the weight is decreased and the socket have improved ventilation and the shape have been changed. Yeah, whereby I can really increase the comfortable of the user. So result and discussion. First, I'm going to show you the animation of my design. Okay, so this is my movement animation that I show you. So the movement actually based on the one knee joint. So knee joint is an important part also to let for the user for bending or sitting when they need to stand up or sitting. Yeah. Now we're talking about simulation. In simulation, I will do the 2 simulation with stress and displacement analysis. So the material was chosen, which is a plastic for socket, aluminum, and carbon fiber, were used for filong and fit. And plastic still applied to socket because it's light and cost saving. Aluminum alloy is used because it's high strength alloy, workability, and also corrosion resistant, and is stiffer and lighter than steel, and is a wet saving material. For the carbon fiber, is the material where high stiffness, high tensile strength, low weight to strength ratio, and high chemical resistance, and also the high temperature tolerance with low thermal expansion. In the stress analysis, we can see that they have 2 diagrams. For the first one is plastic and steel, and we can get that the stress is around 81.91 MPa. For the second material is a plastic aluminum alloy with carbon fiber, you can get an 89.15 MPa. Even though there's a much similar stress that we can get, but in wet saving wise, I choose the aluminum because aluminum is more advantage in a wet saving compared to the steel. So for the displacement analysis, we can see that for the first material, they have a 2.053 mm for the displacement value. And for the second material is aluminum, where I applied aluminum, carbon fiber, and plastic, I get the 0.723 mm. So we know that when the displacement is become small, or the displacement is very small, it is very high strength, or it can say that it's a stable material where we can apply. So I will choose for this material plastic, aluminum, and carbon fiber. Now I want to show you the comparison between a conventional processing lab with a new conceptual design of processing lab. So they have 5 parameters I'm going to discuss. For the first one is weight. So for the conventional processing lab, it's very heavy because of solid design and the material is more to steel. Whereby for the new design, it's a lighter due to hollow at the socket part and the fit. Yeah, and also the lightweight material was applied, which is aluminum and the carbon fiber. When talk about the strength, the steel actually is will apply to the conventional processing lab because it is actually high strength also. But in new design, I choose for another material, which is aluminum and carbon fiber. Yeah, but also have a high strength material. In terms of flexibility, normally in a conventional processing lab, the filong and fit was joined, and actually it can consider as an ease of maintenance as well. For my improvement product, I choose to dismantle into 3 parts, which is socket, filong, and fit, and really help to the for user to do the maintenance and servicing. For the conventional process like reliability based on a solid design actually. But for my improvement product, I increase the flexibility of fit by changing the shape of the fit. And the strength can increase by using the high strength material, where the one fit of the this product, I using the carbon fiber, and I create a hollow that can really help to for shock absorption as well. And for ventilation part, the conventional process like they have no ventilation. By my improvement product, they have a socket ventilation, which is important to avoid the irritation at the type. So this is my orthogonal drawing of my conceptual design tree, as you can see. And this one expoder view and the assemble view, and also the socket orthogonal view, and phelon orthogonal view, and also the fit orthogonal view. So in conclusion, the improvement of prosthetic leg was designed through the TRIS method, and 3 conceptual design was designed, and the best conceptual design was chosen by the patch metric. A comfortable prosthetic leg was designed by reduce the weight and increase the ventilation. Reduce weight helped to increase the efficiency of this product, whereby increase the comfortable of user, especially time. The porous design of socket and foot help to reduce the weight and increase the flexibility. And irritation of skin around the thigh area also can be reduced by applying the preliminary action such as wearing sock, putting sun gel around the thigh and others. Moreover, material component of the conceptual design will choose, which is plastic and socket, high strength aluminum at phelon, and a carbon fiber at fit. Animation of the movement and simulation of material was simulated. So that is my presentation. Thank you so much.